Hi friends, in this video we see control system questions asked in TRB 2017. The first question is, gain crossover frequency is the frequency at which g of omega and h of j omega is 1, right? So gain crossover frequency is the frequency at which the gain is equal to 1, right? So it should be option 1. Phase crossover frequency is the frequency at which phase is equal to minus 180 degree. Please remember that, right? So option A is the right answer. Next, the pole factor 1 by 1 plus j omega t as a slope, right? So they asked the slope in dB per decade. So again we have to find the slope. So what they have given, g of j omega is equal to 1 by 1 plus j omega t. Find the magnitude because gain in dB, right? So mod g, simply write g. So that is equal to 1 by 1 plus omega t whole squared, right? This complex number we find the modulus. So if you write it in dB, it should be 20 log, gain in dB, 20 log 1 by root of 1 plus omega t whole square, that is equal to minus 20 log of 1 plus omega t whole square, right? Okay, now mod g is equal to minus 20 log of 1 plus omega t whole square, right? Okay, suppose if omega t is far less than 1, this implies g mod g becomes omega t is far less than 1 means we can neglect this, right? So what will happen? It will become 0. So it is 20 log 1, that is 0 dB, right? Suppose if omega t is far greater than 1, then mod g becomes minus 20 log of omega t. Yes, because when you are having omega t is far greater than 1 can be neglected, and what will happen? It will be 20 log minus 20 log of root of omega t square, that is equal to minus 20 log of omega t, right? Okay, now what is my g? Mod g is equal to minus 20 log of omega t, where omega t is far greater than 1, right? When omega is equal to 1 by t, let us substitute and find some values, right? Okay, that is equal to 20 log of 1 by t into t, 20 log of 1, 0 dB, right? Then omega is equal to, let us substitute 10 by t. Why I increase the frequency? Why I am not taking 2 by t, 3 by t, or 4 by t? I am taking 10 by t because I want to find the gain improvement or decrement by you with respect to decay. Decay means we have to increase the frequency by 10 times. So I increase by 10 times and find the answer. Now gain becomes 20 log of 10 by t into t. T cancel, minus 20 log 10, that is minus 20 dB. So what happens here, when frequency is increased by 10 times, gain is decreased by 20 dB. So what is that? It is 20 decibel per decade decrement. So it is minus 20 dB per decade is the answer. Why it is 0? Please remember here it is 0 dB, it is minus 20 dB. So minus 20 decibel per decade is the answer. Next one, the gain, if the gain of a open loop system is doubled gain margin, we know that gain margin is equal to 1 by gain, so that is equal to 1 by 2, so it will become off. So option C is the right answer. Next, the term reset control refers, it is integral control system, right? So similarly, anticipatory control is differential control. Please remember that also. Option B is the right answer. Next, what about this? The closed loop gain of the system given below. So here it is a loop gain. What is that? So we know that the closed loop system is given by g of s divided by 1 plus or minus g of s h of s. Plus means negative feedback, minus means positive feedback. Here the feedback is positive. So what is the thing we have to do here? It will be minus, right? 1 minus g of s h of s, right? So it will be 1 minus g of s h of s only we have to take. What is my g of s? G of s equal to minus 2 divided by 1 minus 2 into h of s equal to 1 by 4 as per the problem. If you simplify, what you get is minus 4 by 3. Fine. That is the answer. So option A is the right answer. Next question. The product of branch gains encountered in traversing the loop is nothing but forward path gain, right? So if suppose we are moving from here to here, so let us assume this is G1, this is G2 and G3. What do you think? If you multiply all the things, it will give G1, G2, G3. It is nothing but our forward path gain, right? So okay. Traversing the loop, the product of branch gains traversing the loop, right? It is not sorry, we have to change it. It is, the question is talking about it's traversing the loop, right? So that means what? Suppose it is going like this, it is going in a loop, right? The product, this is one branch, this is one branch. So if it is traversing the loop, it is nothing but your loop gain. So option A is a correct answer. Please change it. Sorry for the inconvenience, right? Next question. State which is not a generalized unity feedback control system. So it is talking about feedback. Simple technology I will tell you. See, out of 4, which one is not having feedback? You see, error detector, we need feedback sometimes. Amplifier, we know feedback is there. Error corrector, we have feedback. In rectifier, we don't have feedback. So it should be option C. Simple answer. Next. For a given system, Routh array is given below. For a given system, Routh array is given below. What is the system? We know that when the first column is having symbol change, surely it is a unstable system. So option B is the correct answer, right? Next, for zeta varies from 0 to 1 by 2. Zeta, what is the thing we know? We know this omega d is equal to omega n into root of 1 minus zeta square. So option C will be correct. Next, for a second order system with a closed loop transfer function, T of f is equal to 9 divided by s square plus 4s plus 9. What is the settling time? For, what is that? 2% band, right? So for 2% band, settling time Ts equal to 4 by zeta omega n, right? That is very important. So denominator is talking about s square. Here we have to compare with the general equation. In general equation, denominator is s square plus 2 zeta omega ns plus omega ns. So what is my 2 zeta omega n? My 2 zeta omega n is equal to 4, right? 2 zeta omega n is equal to 4. This implies zeta omega n is equal to 2. This implies Ts equal to 4 by 2, that is equal to 2. So option B is the right answer, right? So that is simple one. So please remember this point. For 2% band, settling time is 4 by zeta omega n, right? For 0%, 5 by zeta omega n, right? Okay. Next question is talking about the range of k for stability of unity feedback system whose open loop transfer function is given by. So they want k value for system to be stable. So we have to use Routh-Hurwitz criterion, right? So what is that? I will make you simple one. So what they have given, first we need characteristic equation. Characteristic equation given by 1 plus g of s, h of s is equal to 0. G of s is given. It is a unity feedback system. So h of s is equal to 1. So 1 plus k by s into s plus 1 into s plus 2 is equal to 0. if you simplify, what you get is s into s plus 1, s plus 2 plus k is equal to 0. Again, if you simplify, what it will become? It will become s cube plus 3s squared plus 2s plus k is equal to 0, right? K is equal to 0. See, whenever you are having third order equation, it is very easy to find stability. What is the thing we have to do? We find first the product of outer coefficient, right? So this is outer, this is outer. So it will be 1, it is k, so k. Then you find the product of inner coefficient. These two are inner parameter or inner factor. So 3 into 2, 6. Right? Product of coefficient of inner parameter, right? So it is 3 into 2. First find the product of coefficient of outer parameter. So k into 6. For stable system, inner product should be greater than outer product. So 6 must be greater than 6. If it is this, then it is stable. Suppose if you want it to be marginal stable, inner product should be equal to outer product. That means k is equal to 6 will be marginal stable. If you want unstable system, inner product should be less than outer product. So here inner product is 6, that should be less than outer product, right? So outer product is 6. So for stable system, inner product, which is nothing but 6, must be greater than outer product of coefficient, which is nothing but k. So it is 6. So my condition is k must be less than 6. That is our answer. So option B is the right answer, right? Simple way to solve the problem, right? So that's all about this session. If you are having any doubt, please ask me in comment section. I will clarify all your doubts. Thank you.